Okay, so let's do this problem. This is going to be one of the longer ones. Okay? Okay, so first step is to write this as a limit. All right, now we got to do integration by parts on this. And remember, when you're doing this integration by parts problem, whatever you pick to integrate, I'm going to pick the E to integrate the E. Whatever you pick to integrate, keep integrating that. If you decide to switch it around and then start integrating the trigonometric part, basically what you're going to do is undo your work. You're going to prove that 0 equals 0. Okay? So this would be sine of kt, now e to the minus st, now divided by negative s, and then minus the integral from 0 to b. Derivative sign is going to be cosine of kt, and the derivative cosine, the derivative sign is cosine, but it's got to spit out on k. Okay? All right. Now e to the minus st, and once again divided by negative s. This is the integral with respect to t. Okay. Maybe I should have turned the page sideways. I don't even know how to do that. Okay. So I'll continue this problem on page 7. Okay. So that equals, let's just go ahead and deal with the minus sign first. So that's sine of kt, right? Now it's divided by negative s, and then plus the integral from 0 to b of cosine of kt times k times e to the minus st, now divided by s, and this is an integral with respect to t. So all we're doing is getting rid of the minus signs on that one. Okay, so we need to do integration by parts again. Okay? So integrate the e again. Oh. Sorry, e to the minus st. Keep that e to the minus st right there. And so that's going to equal, now the limit as b tends towards infinity. Okay. So this would be sine of kt, now e to the minus st, divided by negative s, okay? And I'm going to integrate e again. So this is a part where it's really important that you pay attention to all of the signs, okay? So, all right, so cosine of kt times k, now write it like this, negative s squared e to the minus st, okay? And we have a minus coming from the integration by parts. Okay? That's going to be 0 to b. The root of cosine is negative, now sine of kt times k squared, now divided by negative s squared, and this e to the minus t, the integral with respect to t. You have to pay attention to all of those minus signs, because we have to have this thing coming out being negative. Okay? The last term needs to be negative, so that we can add it to the opposite side of the problem. Okay, so that's going to equal the limit as b tends towards infinity of sine of kt e to the minus st, now divided by negative s, okay? And then plus cosine of kt e to the minus st, sorry, I lost a k, divided by negative s squared. Okay, minus, 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 this becomes minus, and then we have k squared divided by s squared, and this will be the integral from 0 to b This is going to be sine of kt e to the minus st, integral with respect to t. Okay, now this term right here, this is what we originally began with. That thing right there is the Laplace transform of sine of kt. So what we're going to do is we're going to take this guy, we're going to move all the way back over to the previous side of the problem. And then we're going to have a look at what this right-hand side is going to look like. So we end up with 1 plus k squared divided by s squared, okay, times the integral from 0 to b. I guess I need to keep a limit on this thing. No, let's change it to infinity. Okay? All right, so that's sine of kt e to the minus st, and this is an integral with respect to t. Now this is going to equal the limit as b tends towards infinity. All of these guys right here evaluated at 0 and at b. So that would be sine of kb e to the minus sb divided by negative s, and then plus sine of 0 e to the 0 divided by s, okay? And this would be plus cosine of kb, that's b not t, e to the minus sb times k divided by negative s squared, okay? Let's keep going. So, and then plus cosine of 0 e to the 0 times k divided by s squared. Ooh, that's a lot. Okay, but think about this problem. This is the problem that I was discussing just a minute ago that harkens all the way back to calculus 1, where sine of 0 is 0. I don't care about this one. That's 0, okay? But if I was going to evaluate this one and this one as b, that's a b, not a t. B. So if I was going to evaluate this one and this one right here, what would I do? I would write this as sine of kb over e to the sb, and I write this as cosine of kb over e to the sb. And then I would have to use the squeeze theorem, okay? And so the squeeze theorem, I would say sine and cosine, so let's say sine is just bounded between -1 and 1. So that means that sine of kt would be bounded between -1 and 1. And so we can divide both sides of that problem by e to the sb. And -1 over e to the sb goes to 0, 1 over e to the sb goes to 0, those both go to 0. Hence, by the squeeze theorem, sine of kb divided by e to the sb goes to 0. Okay? So this goes to 0 by squeeze theorem, this goes to 0 by squeeze theorem. And then this guy goes to 0, this goes sine of 0 to 0. And this is the only one that I'm left with. Think about this one. Cosine of 0 is 1, e to the 0 is also 1. All I'm left with is that guy right there. So what's the formula that I'm really looking at? Right? The full formula that I'm looking at is this. So 1 plus now k squared divided by s squared times the integral from 0 to infinity of sine of kt e to the minus st with respect to t is going to equal now k divided by s squared, okay? And now I'm going to divide by the numbers that are on the left-hand side of the problem. That's going to give me the integral from 0 to infinity now of sine of kt e to the minus st with respect to t is going to equal k divided by s squared times 1 plus k squared divided by s squared. Okay, and I can distribute that in there. And so this becomes k divided by s squared plus k squared. And so that is the Laplace transform of sine of kt.